next speaker, Engineer Gaweł, Sołowski, from Institute of Fluid Flow Machinery in Danzig, in Poland. And his talk will be on the hydrogen and methane production during dark fermentation of the sour cabbage with straw cotton under different pH conditions.
Under low conditions, pH conditions. What can say that that we have few time in our world to prevent our lack of our oil, gas, and natural gases. So we had to present different is hydrogen production from food like sour cabbage. In case of dark fermentation, dark fermentation is a case of anaerobic digestion when it finishes after 3 stages, because anaerobic digestion is a type of anaerobic bacterial process that transfer polycarbohydrates into for sugar into methane, and before methane is produced is hydrogen. In case of dark fermentation, our process stops in acidogenesis. So here we have 3 reaction pathways. One reaction pathway is to produce acetic acid, which produces most hydrogen, because 4 molecules of hydrogen. But unfortunately, to gypsum, energy is the least probably from this reaction. Most often occurs butyric acid pathway, which produce only 2 molecules per 1 mole of glucose. And we have here the problem, how this problem can be also solve some medical problems, because our production is hydrogen production is produced by the similar bacteria that causes gangrene diseases, and even it is a legend that Henry VIII, the King of England in 16th century, after being buried, his body explodes because of this bacteria which produce hydrogen, and it's hydrogen. And still this hydrogen, in case of causes destroying of our city, of some energetical problems, some raw material, but also help us trouble with gangrene and with such case, which is very finishing usually by cutting the deaf organ. And now here is my laboratory, and we see that my pH is how our pH is. I prepared 2 kinds of sour cabbage. One is first is case, which is because sour cabbage is cabbage which we give to fermentation of the lactic acid. And the first case is the initial case of our sour cabbage, and the next is more digested. The inoculum was taken from the biogas plant and used as to produce our hydrogen. And here is my laboratory case. So here we have our cylindrical measures that takes hydrogen that is produced by reactors in the jars. And we have some syringe that I use to make a microaeration condition, because little air helps, however it's anaerobic. But small, up to 4, 5, 6% helps to make better results. And here is water bath. This is keeping our temperature, because this bacteria likes temperature between mesophilic temperature of 32 to 38 degrees. And here our results, how our hydrogen yield works. So here we have case of sour cabbage of initial in the red. So we see that oxygen flow rate, so more oxygen gives better results up to 0.9, where we have up to 22 milliliters of hydrogen per gram of sour cabbage. And we see that in case of low gases, so highly digested, mostly works better, mostly produce less hydrogen, besides microaeration 2.1 milliliters per hour. So this is the rate that I use this syringe adding. And we here have the comparison of different initial concentration and different microaeration conditions, also anaerobic, and we see that hydrogen production in case of the same.
You might have seen videos like this before, but here's the big secret. Anyone can make one of these videos in a few.
The same concentration produce twice less hydrogen than in anaerobic conditions. What is reversed that in case of methane production, because in low digested highly digested material is better produced for the methane than in case of low or initial cabbage. And similar thing is that in microaeration worse the methane production, however hydrogen production increases. Here we have the last comparison of different results, and we also managed to find that in case of microaeration we have also little delay in production. What gives us opportunity of dark fermentation to be produced as raw materials for some polymers, but still very low concentration. But the more important is that we can get in this pot, there's also opportunity to produce some other raw materials that are usually produced by fossil fuels, so give some opportunities of this process to different products, but this due to different conditions. And here we have we have different materials that we produce also, so that hydrogen is produced mainly most is cheaper for the starch for potatoes, but most important waste is wheat straw, which has the highest cost, and some cotton waste, but are the most demanded ways to be utilized. So mostly demanded to be a source of our fuels. And what is the advantage of dark fermentation and anaerobic digestion? That can produce raw materials on 24 hours, not like, for example, algae that needs some light to produce this hydrogen, not as photovoltaics or pyrolysis, photovoltaics that needs light, and not so much fusive like pyrolysis. And the conclusion is that in case of 5 grams per 5 grams per liter, the 58 meters per hour gives 15% more hydrogen. Here are my references of my publication that I used, and thank you.